Hi, Mr. Shao, this is Whitney. Now I'm going to explain how did the Voltaic cell work. Okay, now I'm going to draw a graph first. Now we have two electrons. Okay, and this one is the copper, and this one is the magnesium. The reason why we use the magnesium electron is because magnesium is the most active electron. I'm sorry, the magnesium is the most active molecule, which means it can provide the faster reaction. Now we have two sulfate solutions at the bottom of the electron. This one and this one. Copper, sulfate, solution. And this one is the magnesium, sulfate, solution. Then we have a voltmeter on the top of two electrodes. A voltmeter. A voltmeter is an instrument for measuring the electron potential in volt. Then, for the under part of it is our solution. This is a liquid, and this is a liquid. In here, this black line connects with the two electrons, and the voltmeter, we call it wire, W-I-R-E. And here, we have another thing, which is called the salt bridge. It connects between two solutions. Here. Okay, and this is called the salt bridge. And as we know, what is the salt? The salt is NO3, N is KNO3, KNO3. This is the AQ. And because of the K carry the positive electrons, and NO3 carry the negative electrons. So it goes into this way. Okay. The reason NO3 minus and the K plus goes to these two way is because the flow of the electrons, it's because the flow of electron goes this way. The reaction between here, the copper electrode, and the copper sulfate solution, the reaction between here is called half cell. Which just means it actually has the reaction, but we cannot see it obviously, and there's nothing changed. The reaction between here, we can write it into let's write it here. Cu goes to Cu2 plus, which just means it has two more negative electrons than this. This is the solution, which just means it has two more negative electrons. At the same time, the copper sulfate solution, which is the copper 2 minus, it gets these two negative electrons. So it becomes the copper electron. And this whole equation, we call it half cell. And the same thing happens here. Magnesium goes to Mg2 plus and also carries two negative electrons. And these two negative electrons react with another Mg2 plus and it becomes the magnesium. And now what happens in the Voltaic cell is this two negative electrons, it goes to this way. It passed the voltmeter and keep going. It goes to magnesium. At this time, when the negative electron it starts to flows to this way, and when it passed the voltmeter, which is gave the electrons, which is the time that the Voltaic cell start to work. And the Voltaic meter, it shows how much electrons flew by it, which means how much electron it provides. The reason why there is a salt bridge, it is because when the negative electrons flow by this way, there has too much Cooper solution, and it needs to balance. So, as we see, the NO3 minus, it is a minus. It carries negative electrons. So it goes to this way, and the Cooper sulfate, Cooper solution, it goes to this way, and at here, it reacts and stop there. It help to the salt bridge help to balance. And same thing happens here. When it goes to this way, there it also balance at here with the Mg and the NO3 plus. So that only after it balance, the negative electron will keep flow. And this is how we get the electrons. And this is how the Voltaic cell work. And in this case, the magnesium, it gains electrons, which just means reduce. And the copper, it lost the electrons, which just means oxide. And for the salt bridge, it normally is the KNO3 or KCl. It both work for it. And the purpose of the salt bridge is to keep the solution it's for to keep it neutral and allow the free flow of the ions from one cell to another. And without the salt bridge, the positive and the negative charge will build up around the electrodes, and it will make the reaction stop. And for the flow of the electrons, it always flows from the side that the oxidation half and to the reduction half. So basically, that is how the Voltaic cell work. Thank you. Have a good weekend. Bye.